All right, we're here with period 7. Going to go over how to use determinants, which you just took 5 minutes to figure out, and something called Cramer's rule to solve a system of linear equations. Now, Cramer's rule comes from a guy named Gabriel Cramer. He was a Swiss mathematician in the 18th century. All right, so he's dead, so pour one out for him. Let's talk about how to solve this system using Cramer's rule. All right? Now, the first thing you want to do with Cramer's rule, all right, and all of the problems I'm going to give you where I ask you to solve them using Cramer's rule, they're going to be in standard form. This is called standard form, where it's ax plus by equals the constant. They're always going to be in standard form. Okay? The first thing you want to do is to write what is called a coefficient matrix. Okay? The coefficient matrix. And I'm going to label that as matrix D. Okay? What are the coefficients in front of those variables? Those are not the coefficients. 1, -1. Coefficients are in front of variables. 2 and -1. Okay, so hopefully your brain just saw that I took the numbers in front of x and y and made a matrix. Yep. The numbers in front of x and y, I made a matrix. It's called the coefficient matrix. All right, so that's the first thing you always have to do. Because they said subtraction. If it had said plus y, then it'd be a positive one. All right, now once you find that coefficient matrix, find the determinant of that matrix, which is something you just learned how to do. So we're going to do 1 times -1 minus 2 times -1. Well, so far it is. Question? This here, Frank, you good? So this -1 comes from the y. So it says minus y, so that's a -1.
What are the lines on the D?
With the lines here?
Yeah.
What does that mean? It means to do something. Anybody remember? Yes, it means to find the determinant. What we just did. Find the determinant. If you don't like that, you can write DET.
So they equal the same.
Yeah, it's the same thing. Just a different way of writing it. All right, so that's going to be -1 minus -2. And you know I'm going to change that, since it's minus a negative, to write -1 plus 2. So the determinant of matrix D is 1. Okay? So once you get that, it's not the hard part. That's the stuff that you already know how to do, right?
Yeah.
We're not going to plug it in. I haven't shown you what to do yet. So what you're going to do is you're going to solve for x and for y. Well, we're not even close to that. Write smaller. Now, the way you're going to do this is you're going to take this coefficient matrix and you're going to basically copy and paste it where it says x and y, but with one change. Okay? What numbers came from x? What numbers in this matrix came from x? The first column. You see 1 and 2 came from x. So I'm going to replace 1 and 2 with my constants. And what are my constants? 3 and -1. You're good. I'll pause there. So all I did was I copied and pasted this right here. I pasted it there, but I took out this first column because I'm solving for x, and those numbers come from x. And I replaced them with the numbers that are after the equal sign, the constants. Yeah, I'm going to do it again with y. Let me do it with y. Yep. First, yes, the first column came from x, 1 and 2. Okay, now let me do y. Now y, if you look at the coefficient matrix, which numbers came from y? The second column. So that column is going to get replaced by the constants. So you're going to rewrite 1 and 2 but you're going to change the second column to be 3 and negative 1. Well, I mean, it's brand new stuff, right? Correct. Whenever you're solving for x, you're always going to replace the first column, and solving for y will always be the second column, every time. All right, now, you should notice some symbols I use. Nate, this is going back to your question. Notice the symbol that I wrote here. What am I telling you to do with that matrix? To find the determinants. This day is going to be full of determinants. All right, now you're going to divide those by the determinant of matrix D. And in this case, we're going to divide that by 1. Okay? I want to put it like that so you know to always divide by that matrix. Okay, x equals 3 times negative 1 minus negative 1 times negative 1 all over positive 1. If you're asking yourself, what is he doing? I am finding the determinants of those numerators. I'll pause here. Please ask if you're confused by anything. Always dividing it by the determinant of that coefficient matrix, which in this problem, Alondra, was 1. Remember the work that we did at the beginning? This right here. If this had been 11, then I'd be dividing by 11.
Does it matter the order that you put it in when you want to find? Because I got confused on it.
Are you talking about for the determinants? Yes, it matters. This, always think top left, and then do the second one. Always think top left first. Start at the top left. The order matters because you're doing subtraction. Alonzo. Yes, again.
So we're just going to plug in to the bottom right?
Yes, in the bottom is going to be where I put that initial determinant that I found. All right. In this case, divided by 1 is not going to change anything, but you're going to see when you practice, it's not always going to be positive 1. It could be negative 7, could be 14, could be negative 38, I don't know, something. Everybody good? Okay, so let's figure out what this is. That's going to be negative 3 minus 1 divided by 1, and negative 1 minus 6 divided by 1. So what is my answer going to be? Negative 4 and negative 7. There's my solution. It is a lot, right? That's one problem. Okay. Any questions on this? Now, I want you to think back to last unit. Last unit, we had systems that had one solution. This is an example of a consistent, independent, exactly one solution system. Do you remember the other types of systems we had?
Yes.
Anyone? Thank you. Expand. Close. Infinitely many solutions. That's when they are exactly the same line. What was the other one then? No solution, when they're parallel lines. You think that's coming back? Oh yeah, it's coming back. Let's try example 4. Here we go. Let's see if you can do the process again. All right, so we're going to do the same process. Ready? All right, first we need the coefficient matrix. Come on, Josue, you can do it. I'm almost done. Negative 3, positive 1, 3, negative 1. All right, please stop me if you don't know where I got those numbers. I got those in front of x and y. Yes. They're from x and y, always the coefficients of x and y. Okay? Now, I always label that matrix D, but you can use whatever letter you want. It doesn't matter. All right, I don't care. So the absolute value of that, to find the determinant, right? Because remember today it's not absolute value. Determinant is negative 3 times negative 1 minus 3 times 1. So this is going to be positive 3. That's also positive 3, so Savannah is right. 3 minus 3 is 0. Now, whenever you get the determinant for your coefficient matrix is 0, something special is happening.
No solution.
It could be that, Nada. But it also could be infinitely many solutions. It's one of those two. All right? You have to do all of the work to find out which one it is. Sad. All right? Here we go. Ouch. X equals y equals. So, to solve for x, like we did on the last example, I'm going to replace the numbers that came from x. These numbers, -3 and +3, came from x. So they're going to be replaced by 2 and 7. Okay. Those are copied. So let's see if you can do this one, Anthony. What am I going to write here? Nope. -3 and 3. Because, Anthony, we're solving for y. So you keep the ones that come from x, right? These came from x. They stay there. And I take out the ones that come from y, the 1 and the -1. They're replaced by 2 and 7. That's right. Exactly. Always replace for the one you're solving for. You're solving for x, take out the ones that were from x. I think now I understand your question. Yes, after the equal sign. My bad. Those are called the constants, the numbers that don't have variables with them. Okay? Now you should notice I wrote dividing by the determinant of matrix D, but you know that's 0, right? You know that's 0, and I can't divide by 0, but I want you to keep it there. So x equals 2 times -1 minus 7 times 1 divided by 0. And y equals -3 times 7 minus 3 times 2 all over 0. Yes. So like where I put 2 and 7? So I guess what I would say is there's a couple ways to think of it. In the first thing you're solving for x, the 2 and the 7 replace the first column. The second thing you're solving for y, the 2 and the 7 replace the second column. Always. And you're going to practice 4 times soon. 4 times. Everybody good so far? Bless you, bless you. All right, so x equals -2 minus 7 over 0. And y equals -21 minus 6 over 0. So what are my fractions going to be? -9 over 0. Very good. So you're going to analyze those fractions. Is everybody looking at those two fractions? Obviously, I can't divide by 0. But what do you notice about the numerators? What do you notice about the numerators? I don't care what they are. Do you see any of those being 0?
No.
If neither of the numerators are 0, then this is no solution. Now, if you had looked at the fractions, Anthony, and you saw one or both said this, if one or both say 0 over 0, then you're not writing no solution, you're writing infinitely many solutions. No. I'm not. I didn't say it was you, Anthony. Now, I want to make sure it's clear in your brain. You're always doing all the work. If you look and see that it's not 0 over 0 in one or both, you're writing no solution. If you see 0 over 0, you're writing infinitely many solutions. You got to get that sorted out in your brain before next Wednesday. Infinitely many solutions. Any other questions? Now, you're going to try these 4, okay? And it's going to come up. You're going to have one or a couple that have zeros as determinants. All right, so you got to figure out which one it's going to be. All right, good luck. Go.